Hello learner, welcome to Manifested e-learning platform. My name is James Kenyani. We are going to proceed with our topic on reflection and congruence. And it reaches a point where we are beginning a subtopic, reflection. Reflection. In this case, we shall be dealing with mirrors. So it is not the first time you deal with reflection. Wherever you look in the mirror every day in the morning, that is an experience of reflection. So today our lesson will be reflection. But still under reflection, we shall deal with a small aspect of reflection. Mirror lines, shall deal with mirror lines. And construction. Of objects and images of lines and planes. Lines and planes. So at the end of the lesson, the learner should be able to construct objects and images of lines and planes, and also be able to know, to put down or to understand some of the properties you get when we have that reflection. So the objective at the end so apart from constructing, you, the learner, you are supposed to notice some of the properties. Some of the properties are even evident. Like for example, when an object is just on the mirror line, it will not change. As aspects like distance, you'll find they'll not vary. So to go to that, we shall start with image of a line. So to start with, you must have your mirror line. Mirror line. You can abbreviate it using M. And in most cases, many will use that side to show the polished side. The other side is the one that reflects. You can always use M to show the mirror line. So if we have our objects, we have our object. So our object is the line AB. I want to get an image there. You'll notice that once you have this, this will be the mirror line. What you do in such a case, you take your pair of compass, and notice that in reflection, we always use the shortest distance to the mirror, which will be the perpendicular distance from the end point. You'll use the end points and get the perpendicular distance to the mirror. The perpendicular distance to the mirror. So you'll come here with your pair of compass. Notice what will happen. I want to strike a perpendicular here. Since my mirror line was short, I'll be forced to prolong it to accommodate that arc. I prolong it to accommodate that arc. After getting this point and that point, it helps me to drop a perpendicular there. Just comes to sum up some of the properties we'll get. The distance of the image and the distance of the object. We are using one of those properties to construct this. So you'll take your compass, strike above, strike below, maintain the same distance, strike here, strike below. After getting that, take your ruler, and I said you are using one of the properties to get that, the distance of the image from the mirror and the distance of the object. Actually, we shall get that they'll be equal. So after doing that, prolong a line, and you'll notice it will be perpendicular. So in front of the image, make it continuous. Behind the polished side, make it dotted. Make it dotted. After doing that, which highlights one of the properties you shall get, the distance of the object from the mirror will be the distance of the image from that mirror. So you'll take this distance at the intersection. It's there. You strike there. So this image, I'll call it A prime. I'll call my image A prime. A prime. I've got the image of A. What do I notice? The distance from the mirror to the object and the distance from the mirror to the image is the same. So I'll come to B. Do the same. You'll find I'll get 2 points. This point and that point. Those ones help me to drop the perpendicular. So I'll come here, strike above, strike below, remove, remove. So the point will help me to drop that perpendicular. Or a perpendicular. So in front of the image, let it be continuous. In front of the mirror, behind the mirror, dotted. Behind the mirror, let it be dotted. The distance of the image, distance of the object, the same. So that's why you'll come and use the same distance. Above, below. So I would have got I would have got the image of B. So I'll call it B prime. Call this B prime. So I'll join so that is the image. You take the line as the object. So just using that, there are some properties we can deduce. Properties in reflection. What properties do you notice? A point on any point on the image, a point on the object is at an equal distance to a corresponding point on the image from a point on the object is at an equal distance to a corresponding point on the image from the mirror. Or what you can shorten is mirror distance. Object distance is the same as image distance. You'll also notice if I have a point here, a point on the mirror line does not change. Mirror line is invariant. Invariant means it does not change. It will just remain there. It will be invariant. Number 3, size of object and image is the same. Size of the object image is the same. Another property you'll notice, a line like this line, it never changed direction. A line parallel to the mirror, a line parallel to the mirror in the image will not change direction. Parallel to the mirror does not Similarly, we shall look at a line perpendicular to the mirror. A line this line, so I'm just using this one. It will reverse the direction. It will be in the opposite direction. Those are actually the properties of reflection. The object distance and the image distance is the same. A point on the mirror will remain there. It will be invariant. 3, size of the object and the image will be the same. A line parallel to the mirror will have the same direction, and a line perpendicular to the mirror reverses direction. So we shall, if we have a triangle, and so that is a triangle, ABC. So as usual, I should have the mirror line. Notice that the mirror line doesn't need to be horizontal. It can be vertical at any angle, so long as the properties of reflection are followed. So as usual, I denote my mirror line with M. That is my mirror line, and you can put that for the polished side. That means it is not the reflecting side, it is polished to give the mirror its reflecting properties. So I want to reflect my triangle ABC on that mirror line. And notice here in the properties about distance, it was a perpendicular distance. Always remember, the shortest distance to the mirror is the perpendicular distance. That's why I constructed a perpendicular to the mirror, and the distance remained the same. So the same properties, I'm going to use them when constructing the perpendiculars for that. And notice here the images are A prime, B prime. So I'll come here. I'll start with C, very near to the mirror. Strike an arc there. Remove the two arcs, help me to create a perpendicular. Drop there. Strike an arc, learner. Strike an arc. Remove carefully. Stamp there. Strike an arc. Strike an arc. After striking, you join. You actually join. You'll join. Join this, and where on the image side, on the object side, you'll actually have a continuous line. Have a continuous line from C. On the other side, have dotted. After doing that, take that distance from the mirror line, because this is now perpendicular. Properties of reflection. Stamp there. It is actually a very small distance. Strike there. I would have got my C prime. C prime. Do the same for A. For A. Strike an arc. Strike an arc. Remove. For the perpendiculars, strike an arc. Strike an arc below. Remove. Strike an arc. Strike another arc below. Then you join. You'll get the perpendicular. So on this side, you make it continuous. Below, because it's the image side, you make it dotted. So get that distance for A prime. So my A prime is here. That is A prime. Come to B. Do the same thing. Drop a perpendicular from the object to the mirror line. So I need to stretch it a bit so that I get the arcs. Those are the arcs. Remove there. Come there. Strike your arc. Strike your arc below. Remove that. Come here. Strike an arc. Strike an arc. Join. Where we have the object continuous. On the image side, dotted. So here, you'll have continuous. On the other side, have dotted. After getting that, use the same distance from the mirror line to B. It will be the same distance from the mirror line to the image B prime. So that is my B prime. I remove. I've got my B prime. So I'll join the vertices. I'll quickly join A to C, A to C. So that is the reflection of triangle ABC. And you notice the properties do not change. But as we sum up, we've actually got the meaning of reflection. Reflection is a flip. Reflection is a transformation representing a flip of the image. I've just flipped. So from there, the properties have not changed. So from all this, we realize that reflection is a transformation representing a flip of the image. You've actually seen in that. So at this juncture, you should be able to construct object of a triangle and get its image and also a line. That's why for the assignment, construct an equilateral triangle of 5 centimeters and reflect it on any line of your choice. You can choose to put the line anywhere. It can be here, anywhere, so long as the properties of reflection are followed. So at that juncture, I close up the lesson, and I hope the properties have been taken in and the construction procedures are followed. So make sure you do that before we meet in the next lesson. So bye and have a good time. Thank you.